Married Monday the 7th of December, you guys will be able to use CPCTC, we'll figure out what that means, to prove triangles congruent. Section 5.3.
I'm already exhausted.
Yes. If we look up here, CPCTC stands for corresponding parts of congruent triangles are congruent.
Why is you saying that?
Because those aren't included in the acronym.
Corresponding parts.
Yeah.
Okay. We have this thing called congruent figures, okay? Figures that are congruent will have the same size and shape. So you aren't going to have like a triangle be congruent to a square because those aren't the same shape. Okay? And they're going to be the same size, just as big or small and same dimensions, okay? So corresponding sides that go together, they correspond if they go together, okay? And corresponding angles are congruent in congruent figures. Yes, Bill?
You should be happy today. You're getting tons of raises.
That's the goal. Okay. Congruent statements, okay? So it's statements saying that two things are congruent. For the two triangles shown, for the two congruent triangles shown, we can write the following. We can say triangle ABC is congruent to triangle FED. Now we have to be careful here. The order matters, okay? If you look here, triangle A, BC, and triangle FED, they follow in order. The first letter in each is A and F. Well, if you look at angles A and F, are those angles congruent to each other?
Yes.
Yes. If we look at the second letters, angles B and E, are those two angles congruent to each other?
Yes.
Last letters, C and D, are those congruent to each other?
Yes.
Yes. The order with these matter. Okay? Now, we could also rearrange it. If we wanted to, we could call the first one angle CBA. But that means we have to change up the second one, very similar to slope. Does anyone have an idea of what I might have to call the second one if I call the first one? It's triangle CBA. Okay? You said what? Okay, it would be triangle DEF, okay? Because angles C and D are congruent, angles B and E are congruent, and angles A and F are congruent. To follow the same exact order. Okay, does someone want to give me a third combination we could do? Okay, there's a lot of different combinations. Someone want to give me a third one? Okay, go ahead, Aiden.
Angle cab.
Triangle what?
Triangle cab.
Okay, triangle CAB.
And DF. And it's going to go to triangle DFE.
Okay, it is congruent to triangle DFE. I would agree with that. Triangle cab is congruent to triangle DFE. Okay, defeat. Okay? So we'd say, okay, well, what are our corresponding angles here, okay? So I would say angle A and, I'm going to put it in like an and symbol, okay? And angle F are corresponding. Okay? Who can tell me another set of corresponding angles here, okay? I'm going to put a comma. Who can tell me another set of corresponding angles here? Okay? Angles B and E correspond. They go together. Okay? And by corresponding going together, we're meaning that they're in the same place of that triangle, okay? They're in the same place of that triangle. Now, technically speaking, corresponding angles don't always have to be congruent. But when the shapes are congruent, when the figures are congruent, they will be congruent, okay? So, because angles B and E correspond in these congruent triangles, they're congruent, okay? Who can give me the last set of corresponding angles?
C and D.
Okay? Angle C and angle D.
I like the CD.
Okay?
Lamb.
There you go. Okay? Now, corresponding sides, okay? These are going to be sides that are also congruent to each other, okay? Who can tell me a set of corresponding sides? Okay, Dominic, go ahead.
Side AB and side FE.
Very good. Side AB and side FE are corresponding, okay? If you notice, they're both on the same side of the triangle. They're both on the left here, okay? And they are congruent. Now, another way to notice, okay, is if we look back up to our congruent statement, AB is the first two letters, FE are the first two letters. First two letters, they correspond, okay? Kelly.
This might be like a little bit of a dumb question, but like, if you turn one of them, does that change anything?
Great question. So if we were to turn a triangle, let's say we were to like just like copy and paste this triangle, and like all of a sudden it's here, and like this is F. To me, this is E. This is an E. This is an F, and this is a D. Okay. All of the things being congruent would still be the same. So this would still have like one arc. This would still have like two arcs, and this would still have like three arcs. Okay. So angle E would still be corresponding to angle B. So even if they're faced different directions, We have to kind of imagine what they would look like if they weren't facing different directions. Great question, okay? Yes, Max.
That maybe because they still have the same, like, the sides all have the same dimensions.
So that's part of it is they still have the same measures, but also those would be the ones that would go together if we were trying to make them congruent even. Yeah, great question, okay? So can somebody give me another pair of corresponding sides here? Okay, Liam.
B, C, and D.
Okay, sides B, C, and side ED. Very good. Okay, those are both in the top right, and they both have three marks there, so they're both congruent to each other. Another way to think about it, too, is also last two letters, okay? Can somebody give me my third and final pair of corresponding sides, okay? Aiden.
Line CA and line FG.
Okay, so it'd actually be line segment, just so we're, just a heads up, but yeah, line segment CA and line segment, did you say DF or FE?
FD.
Okay, FD. And it really doesn't matter which order we put that in, DF or FD, but I just wanted to make sure I did whatever he said. Because I wanted to put whatever he had on there. Okay, so first and last letter, bottom of the triangles, congruent to each other. Another way to think about it too is they're both between the angles with 1 and 3 tick marks or 1 and 3 arcs. Angles between 1 and 3 arcs. Okay, so there are multiple ways to think about this. Questions on telling whether things are corresponding and what that means, all that stuff. All right, so we're going to identify congruent parts. So I want us to write a congruent statement for these triangles. And so do we see these triangles facing the same direction right now?
No.
No, okay, so this is actually exactly what Kelly's question was, okay? So according to these diagrams, triangle ABC should be congruent to triangle what? How would we have to word the second one? If the first one's triangle ABC, how would we have to order the second one?
FGH.
Okay, FGH. I would agree with that.
Wait. Yeah.
Okay. If we look at angle A, that does look to be congruent to angle F. Those are the right angles. Okay. Well, angle A to B, okay, that's following the 2 tick marks. So we have to follow 2 tick marks, F to G. Another way to think about it, go to the 1 arc angle, B to G. Then the last one has to be the other remaining letter. But we could also use the same sort of strategy to get there. Any questions on how we knew that?
Because of math.
Okay, so I want you guys to go ahead and fill in what these corresponding angles and the corresponding sides would be and say, hey, this angle is congruent to this angle, this side's congruent to this side because they're corresponding right now. So go ahead and finish this part out. Anna, angle A is congruent to what angle?
F.
Awesome, angle A is congruent to angle F, okay? Levi, angle B is congruent to what angle? Awesome, okay? And then angle C is congruent to what angle, Seth?
H.
Very good. It's angle H, okay? Corresponding side. Side AB is congruent to what side, Saren?
G.
Nope. Side AB is congruent to what?
FG.
Side FG.
I thought you said just B.
Ah, gotcha, okay. Kelly, side BC is congruent to what side?
GH.
Okay, very good. And then Israel, side CA is congruent to what side? Okay, HF, very good. And we could word that FH, HF, it really doesn't matter. Okay. Here on the right, okay. Without drawing the shapes, can you determine if triangles? Can you determine the following? Excuse me, these 6. If we know this information, triangles YRT is congruent to triangle MBC. Can we know these following informations with only looking at the diagrams?
Yeah.
Yeah, we can, right? We just have to match with the letters, right? Okay. So, who wants to help me on number 1 here? Okay, Aiden.
Upside down 7 and 5.
Angle Y is congruent to angle M, okay? Bill, number 2. What's congruent to angle C?
Angle, I don't know, H?
Did you say H?
Yep.
We don't have an angle H.
I think I'm still looking at
That shows.
I think you're still looking at the other one as well. Do you want to try again here? Or do you want to try it again on a later problem?
T?
Okay. It would be angle T. Very good. Third letter, okay? Levi's making a T there with his hands, okay? Liam, what's congruent to side BC?
Side RT.
Okay, side RT. Very good. Okay. Yes, Aiden.
No, I'm just gonna.
You want to do the next one? Okay. Jacob, actually. Number 4.
TY.
Okay, TY or YT, very good. That side is congruent to side CM. Okay. Aiden, go ahead and help me with number 5. That is an interesting way to put that. Yeet without the e's. Okay, so YT. Okay. Now,
It almost had me there.
yeah, on 4 and 5 we were careful about the order there. We really don't have to be though. Heads up. You could put the same one. Kind of tricky. Number 6. What is congruent to angle B? Okay, bless you. Must raise down after. Let's forget. Ireland. What is congruent to angle B here? Angle R. Very good. Okay. Any question on this, guys? Okay, I feel like you guys are understanding this decently well at the very least. Okay, is that accurate? Okay. Determine whether the given triangles are congruent and explain why. Okay, so let's take a moment to look at these. Don't blurt. Okay, take a moment to look at these though, and why don't you think about whether or not these two triangles are congruent or not. Okay.
That was so
That
bad.
was so
Does anyone want to answer this first one? Whether or not they think the triangles are congruent or not?
I do.
Okay, you think they're congruent? I agree. Triangle. Give me a statement. Triangle. This. Congruent.
Triangle
Because they have the
J,
same size and shape and
G,
have corresponding units.
H is congruent to triangle M, K, L.
I just put a congruent sign.
Awesome. Triangle GH is congruent to triangle MKL. I would want a legit congruent statement like this. This is our congruent statement. This triangle is congruent to this triangle. Now, the first one did not have to go in that order, but because it did, the second one has to go in that order, okay? And we also want to explain. Kaya, you were saying something about the explanation here?
Yeah, I actually put words down.
Yes.
Yeah, same.
You, Grips.
What did you say for your explanation?
Yes, because they have the same shape and size and have corresponding sides and angles.
Okay, and so I love that. I'm actually just going to take the last part of that, okay? So why are they congruent? Well, you could say, well, because
They have corresponding
all corresponding parts
It's corresponding to
Corresponding.
Because Mr. Castle said so.
Because I said so. What's the abbreviation for corresponding?
are congruent. Corresponding, COR. Yep. These all corresponding parts are congruent. Okay, that'd be enough for us to know. If every single corresponding part is congruent, the triangles have to be congruent. Because that means all their angles and all their sides match up, same size, same shape. They have to have those. Questions on that?
Nope.
All right, let's look at number 4. Okay, not number 4. I didn't number this. Okay, the bottom right. Okay, don't blurt. Just like on the previous one. Think about it.
Look.
Okay, raise your hand if you think you know or you want to share. Okay, Bill.
I think it's not congruent.
Okay, why do you think these are not congruent?
It says 8.4. The other one says 8.5.
Ah, yes, okay. So you could say not congruent, and you could say a reason. You could just simply say 8.5 is not equal to 8.4. That would be enough of a reason, okay? If you wanted to write out some other words, what might be something else you could say? Levi?
8 point. I put line BC is different from line BF.
Okay, line BC is different or not congruent to line BF, or excuse me, DF. That'd be a great explanation. Jacob, did you have the same one?
No, I was gonna try to get line 8.5 dot not equals 8.4.
All right, medieval, okay? Gauge.
I don't know, I just did what we did for there, except I said because not all corresponding are equal.
Okay, that's good. Not all corresponding parts are congruent. That'd be good to know. Okay. Yeah, and so do yours, okay? Anyone else have any ideas of how we could write these?
That's not very nice.
Jesus.
Okay.
Mr. Castle, I could read.
Jesus is Belgian.
It's true.
You would only get a
Mr.
raise for
Castle
me
shows
if
no
it
mercy.
was gone.
All right. Oh, what if I make you yawn enough to where you cry?
Oh, that's true. Then.
Okay.
Like get raised.
Loopholes. Okay.
Oh, yikes.
Got to get that paper, you know. All right. So given that triangle ABC is congruent to triangle DEF, so we're given that the triangles are congruent. Find X and Y. Okay. Well, can somebody help me set up the equation? We always have to find equations, right, in order to solve the variables. Okay. Can anybody help me set up the equation to find X? Okay. Anna, could you help me do this? No, okay, we'll phone a friend, okay? We'll phone a friend. Anna, do you have anyone you want to pick? No, okay, I'll pick someone, okay? Kaya.
We're finding.
X.
Oh, I was gonna find one.
Okay, find Y then.
Okay, so 46 plus 50.
What?
Or
There's
yeah,
no Y in that variable.
This is math.
just a minute. Plus y equals 180.
There's no Y.
We don't know that to be true.
Adding.
We don't know if angle A is y or not.
She just trust me.
Okay.
That we don't know that, unfortunately. Okay, Max.
The 2y minus 8 is equal to 50.
Okay, what's your reasoning for saying 2y minus 8 is equal to 50?
Because both the triangles are congruent.
Okay, the triangles are congruent, so angle C has to be congruent to angle F, right? Because those are corresponding parts. Okay, because if we look at the letters, C and F, they match up. Okay, so these are corresponding parts. Congruent, we can set them equal. Cowbell should be going off her head, telling him to set them equal. Questions on how we got this equation?
Yes.
Bill, do you have a question on how we got this equation?
I think it's
Oh, okay. So we add 8, and Bill, what do we end up getting after we add 8 and divide by 2?
like everything, y equals 24.
29.
Oh
Your
my.
math
Y
ain't
equals
right.
29.
It is.
You did 48 divided by 2 instead of 58 divided by 2.
You get 56.
58. So we have
I
to...
don't like math.
Sorry, buddy.
I need Will.
I don't know him, okay? So y is 29, okay? Does anyone have any ideas on how we could find x?
Oh, I got X. Let me redeem myself.
Okay, yes, Will, you can redeem yourself. Bill, you can redeem yourself. Who's Will? Anyway. Okay, well, how did you do that?
So, see, it says ABC is congruent to DEF.
Yep.
So it says 21 centimeters. So
Yep.
I'm just getting that.
And that's congruent to side AB, right?
Yep.
Because DE and AB, first two letters of each. So we can do x plus 12 is equal to 91. Subtract by 12. We did our math right this time.
Yeah.
And x is 9. Questions on that one?
Redemption.
I just got it. I was
All right.
looking at it for like 5 minutes. I'm like, I'm so confused.
Happy you clicked, happy you clicked. Does anyone else have any questions? Yes, Kelly.
So like on a test, if
Yep.
you did like this problem differently, would you kind of wrong?
What? How did you do it?
Because like honestly, because like I was just gonna add up like the other two angles and then add 12 to it and then just like subtract that from where you usually
Add 12.
because of 8 because this oh that's the side. Or you just like added that and then subtracted more.
Yeah, I mean, that'd be more work, but I mean, you would still end up using the same properties. So saying like, so would you say like, oh, this is 46 degrees, and then this angle up here at the top is 84 degrees. So this one over here has to be 84 degrees, and then add these three up to 180.
So what I'm saying is like I would add 46 and 50.
Yep.
That would be 96. And
Yep.
Just subtract 96 from 180 and then I would find like, the thing.
Yeah, that'd be 84. But we were finding.
This side, yeah. Then
Oh, but you're thinking 84 equals x plus 12. Oh, okay, gotcha. That makes more sense. Okay, all of a sudden you're like, how else would you do it? Okay, all right. Any other questions on that one?
Y.
Alrighty. Third angles theorem. We already found y. Y is 29. Okay, anyway. So the third angles theorem, okay? If two angles of one triangle are congruent to two angles of another, the third angles also have to be congruent. Think about that for a second, okay? So let's say we just pick random measures for angles B and E since they're congruent, okay? Dominic, what do you want those measures to be for B and E?
B and E.
Yep.
34.
Okay? So angles B and E are 34 degrees now. Okay? Somebody else pick a measure for angles A and D. Okay? Sierra.
41.
Okay, these are 41 degrees now.
Page I know.
Okay? So now, if angle A is 41 degrees, angle B is 34 degrees, angle C has to be whatever 180 minus 75 is, right?
Oh, yeah. That's
Because of 34 plus 41. Okay? Oh, yes. So this is 105 degrees. Now, would we have to do the same exact math to find angle F?
Yeah, no.
You would.
Yeah, because those angles are the same. So if we have two angles congruent of triangles, the third angle, they have to be congruent. There's no option because they have to add up to 180 with the same two numbers. Questions on that?
I do not.
Okay. So the blank there is congruent, by the way.
Third angles theorem.
Yes, third angles theorem.
Oh no.
All right. Anyway, so this example, it says extra. It's really not extra. It's just a normal example, okay? Okay, so we want to find the measure of angle Y, X, W. So we want to find this big angle up here, okay? Now, this looks confusing, right? How many triangles do we see?
3. There's actually 5.
4.
3.
There's 5 triangles here, okay? So you see this triangle.
Yeah,
You see this triangle.
2.
You see this triangle. You see this triangle.
Oh.
And you see this triangle. We actually see 5 triangles
like
here.
One of those, like,
Facebook post.
Yeah.
yeah, that's like one of those.
Yes, yes, yes. I do too. All right. So we really see 5 triangles here. Here's what can help. Okay. Okay. How I would advocate or suggest looking at this is looking at it as 2 big triangles that overlap. Okay. I would look at it as 2 big triangles that overlap. And so something that can be helpful with this is to actually split these up. And call this the triangle XYW that was over here. And have the markings that go with that. So we know W had 2 arcs and it was 40 degrees. We know Y had 1 arc. But we actually don't know anything about this angle X because angle YXW is the angle we're trying to find. And then I take the other triangle. We know Z has 2 arcs. This Y, we don't know any information on the big Y. And this X has 1 arc and it's 35 degrees. So I separated the triangles out. So they were overlapping. And I just said, okay, let's separate them out. So we still see X. We still see Y. But I separated them out. Does anyone have any questions on how I did that? Okay. I think if you have questions on why, I think that'll make sense after we end up getting it. Okay, as to why it might clear things up for us. Because this might be, or excuse me, actually this might even answer the why. Because is this a little bit easier to look at in the red and the blue than over here?
Why are you talking?
What?
Like WHY? Or the literal Y?
I'm talking about, does this make more sense than this?
No. I like doing it like that.
Okay, if you like the one on the left more, you can do the one on the left. Okay, if you like the separated one, we can do the separated one. Okay, we're gonna practice the separated one, and then we're gonna say, oh, this can also work on the other. So we want to find the measure of angle YXW. Okay, well we know these 2 angles are congruent, right?
We do? We do.
Yes.
2 arcs, 2 arcs. So what's the measure of this angle?
40 degrees.
Okay, so we know this measure is 40 degrees. Okay, do we know these 2 angles are congruent?
Yes.
Angles X and Y.
Yes.
No.
1 arc, 1 arc.
But that one's. Oh, yes.
35
yes.
degrees. What's this measure?
35 degrees.
So can we use our third angles theorem to say these other 2 angles have to be congruent?
We can.
Yeah, and now we can also even just find the angle by subtracting from 180, right?
Yes, we can.
Does that make sense to you guys or no?
I got 70.
Okay. I'll disagree. Okay. I do think it's 105 because those other 2 add up to 100 and or excuse me, up to 75. So check that from 180, we get 105. So what is the measure of angle YXW? 105 degrees.
Oh yeah, we're talking about the whole. Yeah, because I haven't split up yet.
Okay, yep. And so if you didn't split them up, okay, you would just have to look in here and just try and visualize this basically without doing this, okay? You do it the same way, except for you're just visualizing what we're trying to make easier to visualize over here, okay? So for you, it makes sense to visualize it here just fine. Go ahead and do that just fine. And say, oh, okay, well, these angles are congruent, so I know, okay, well, this is 40, this is 35.
And if they're both 35, then the one is 100.
Okay, then yeah, this one down here would have to be 110. Okay, which actually though, it can help us a little bit. Then we know that this is 70, and this is 70, and then you can know this is 70 as well. And so then you can add on to get 105. So you can do it that way as well in that triangle. So there's a couple of different ways you can go about this.
You
Okay.
did way too many things.
Okay, whatever of that made sense to you, latch onto that. Forget the rest. Gucci or no? Gucci? No. Gucci? No. Gucci? No. Okay.
It's like a.
Moving on. Okay. Given that triangle ABC is going to triangle DEF, I want you guys to find X. Don't blurt.
Yeah, you screwed.
But I want you guys to try to do it.
Calculator, I don't want to do this.
That's what I'm in the morning.
Israel, help us out here. How do we do this problem?
Well, the equation is just x plus x minus 58 plus 40 to get back to
Okay, but how do we know that works? I agree with you, but how do we know that we can do that? There's some big brain action going on behind the scenes to get there.
So to make it congruent, you have the one angle
Yep.
is the same as angle E.
Yeah. Yeah, angle angle B and angle E are congruent, like Israel said, because we know the triangles are congruent and they're both the second letter. So now we know this is 40, and we know all these three angles have to add up to 180. Very good. Any questions on how we got this far? So now we let our algebra wheels kick in. Okay, we solve this problem.
Huh. What wheel?
We end up getting 2x minus 18 equals 180. 2x is equal to 198.
Yep.
Divided by 2. X is 99. Now, could we go back and find the measures?
Good.
Sure. Do we have to?
You do not.
Super don't.
Super don't.
I did it.
Bro.
Okay, if you go back and find them, though, can you double check your work?
No.
Sure, because they add to 180. Or they should.
No, if you want to do 99 by 2.
Okay. You can check part of your work that way, yes. Okay, any other questions on this?
Do we have
Okay, hi, go to Mr. Carlson, nice to meet you. Okay.
Nice to meet you.
All right. Reflexive property for congruent triangles. You guys remember the reflexive property?
I don't want to.
What did the reflexive property basically say?
If you flip it, it's the same thing.
They're like the same thing
You can
because they're on the
switch
same
them.
sync side.
If you flip it, it's the same thing.
Don't choose like.
That's the symmetric property. Symmetric property is if you flip it around. It equals itself. Or something's congruent to itself. Okay?
No.
So, for any triangle ABC is congruent to
Triangle ABC.
triangle ABC. Any triangle is congruent to itself.
How does that prove anything? Like, why do we need that?
The symmetric property, we actually will use that as some proofs, okay? The symmetric property of congruent triangles. If triangle ABC is congruent to triangle DEF, then what do we know by the symmetric property?
Then ABC is equal to
D, E,
DEF.
F, triangle D, E.
It's equal to ABC.
Oh my gosh.
Are you serious?
The symmetric property tells us we can just flip it around.
This is literally
Wait,
too
did we
smart.
skip something?
No, we didn't.
Nope. Then we have our transitive property.
No.
If triangle ABC is congruent to triangle DEF, and triangle DEF is congruent to triangle JKL, then raise your hand and tell me, Gage.
ABC is congruent to JKL.
Triangle ABC is congruent to triangle JKL. Cut out the middleman.
I can feel my brain simultaneously gaining brain wrinkles and losing brain wrinkles.
I can't
understand a single word of this.
What do you mean?
I'm kidding.
Oh.
Okay, let's look at this figure to the right. Let's look at this figure to the right. Voice off, voice off, voice off. Real quick, we're almost done. We're almost done. If you look at this figure to the right, this is the last thing we're doing today.
Yeah, we are.
Okay, like legit. Okay? So, yep. Okay. So we have two triangles here smushed together, right? Okay, to form a rectangle. Okay. Now we know in this triangle we have three sets of corresponding congruent angles. Do you guys agree with that? Three sets of corresponding congruent angles. Okay, we have the right angles, the one arcs, the two arcs. How many sets of corresponding congruent sides do we have?
2.
Two. Is that enough to say these triangles are congruent yet?
Yes.
No.
No, because we need all sets of corresponding sides and all sets of corresponding angles. Because even if one side is different, like we saw earlier, 8.5 and 8.4, they're not congruent. Sarah, put it away. Okay? Now, is side FH shared between these triangles?
It is.
Is side FH congruent to side FH?
Yes, it is.
It is by the reflexive property. So now, could we say these triangles are congruent?
Yes.
Yeah, so we can say triangles, maybe FHG is congruent to triangles OHFE. So make them the same order. And now here's what we can say. Instead of saying because all corresponding parts are congruent, you could say by
Reflexive property.
CPCTC.
Why?
Because that means corresponding parts of congruent triangles are congruent. So we're actually using that to prove the triangle's congruent now. We're going back to the CPCTC thing. Corresponding parts, all the parts that go together, of congruent triangles are congruent, have to be congruent. So the reverse of that, the converse of that is that. What was that?
I forgot this is
Ooh, okay. We're actually going to skip the portion on the next page that says triangles with the coordinate plane. Good luck. Okay, yes.
So it tells me we just proved that a diagonal line to a rectangle is symmetric.
I mean, I suppose. We also just proved that a line is congruent to itself.
Wow.
Yeah, but like, I'm talking about like, now it's symmetric, right?
Oh, yeah.
The shape is symmetric to this line.
Yeah.
So you telling me rectangle?
Oh, no, it's not symmetric. No, it's not.
Yeah.
Oh, no. You're saying it has like line symmetry? No.
Yeah, like you put a line.
No, we try and flip it over that shape though.
We just proved it.
No, try and flip it over that shape. We proved congruency, not symmetry.
Liam, don't be
It's the same shape.
Don't be Max, Liam.
We'll be like, with my phone.
Jake, I'm already done.
Don't do number 11.
Yeah!